In this video, we will deal with standard derivatives and designing questions based on them. This is an area of importance for many students in high school, and this video will be useful to them. Let us begin with the derivative of x raised to n. So dx raised to n by dx equals n times x raised to n minus 1 when n is not equal to 0. We will not be dealing with the derivation of this of standard derivative, but we will focus our attention on how questions are framed by using this form. All the questions designed are based on one fact, that the concept of variable, you can have a function as a variable, and in composite functions the variable is the base function is a variable which may be dependent on some other variable. So there is a chain of variables. For example, x square, sine x square, log of sine x square. So these are functions built on basis of the other functions. So our whole focus is treating a function as a variable helps. So as per our choice of convenience, we should be able to treat a function as an independent variable. Let us consider the derivative of sine raised to n x with respect to sine x. So d sine raised to n by dx, when you consider sine x as itself as a variable, we know that sine raised to nx is the nth power of sine x. So if we apply the standard derivative of dx raised to n by dx equal to n x raised to n minus 1, we will be able to get d sine raised to n by d sine x equals to n times sine x raised to n minus 1, which is same as n times sine raised to n minus 1 x. Or for example, if we have log x as a function, as the variable, and we raise log x to the power n, we will be able to use the find the derivative of log x raised to n with respect to log x as n times log x raised to n minus 1. This is the first simple application of function as an independent variable. Now we know that sine of 3x is equal to 3 times sine x minus 4 sine cube x. If you are unaware of this fact, refer to our video formulas for sine x plus y and cos x plus y and their use, which is available on this channel. Now we design the question instead of directly designing it. We design the question this way: d 3 times sine x minus 4 times sine cube x whole raised to 7. So basically what we have done is sine 3x raised to 7. So it is in this form itself that x raised to n, finding derivative of x raised to n with respect to x. Here our variable is sine 3x and the power raised is the 7th power. So this is what we will be able to achieve using this. So the derivative will be 7 times sine raised to 6 3x. Let us look at another standard expression for derivative. d dx of a raised to x equals a raised to x times natural logarithm of a. We can build various problems based on this by using a function instead of the simple variable x. So x can have different forms in this case. For example, x sine x square sine cube x, or some polynomial like x cube plus 3x square plus 2, different things. Let us begin with the case of the function being x sine x. There is nothing sacrosanct about x. Uh, you can use other symbols y, z, t, whatever you feel like. So d a raised to x sine x dx sine x. So that is the derivative of a raised to x sine x with respect to x sine x will equal a raised to x sine x times log a. Similarly, derivative of a raised to x raised to n with respect to x raised to n. So dx raised to n of a raised to x raised to n will be equal to a raised to x raised to n times log a. One builds variations by combining 2 or 3 different standard forms also. There is a chain rule for derivatives. That is, if there is a different function, dependent composite function rule. So for example, if you take sine 2x, then sine of 2x square, sine square of 2x is a different function dependent on whose independent variable is sine 2x. So you are taking square of sine 2x or cube of sine 2x. So we have uh, adopted that to bring in a variation to the problem, unless you know the chain rule of derivatives and the fact that sine of 2x can be expressed at 2 times sine x cos x. The problem built is now find the derivative of a raised to 4 sine square x cos square x with respect to sine 2x. So d sine 2x of a raised to 4 sine square x cos square x equal to question mark is the question. This is solved by first recognizing that 4 times sine square x cos square x is equal to sine square of 2x, and so the first derivative, since this would be of the form uh, a raised to x, so d a raised to sine 2x square and with respect to sine square of 2x, if we take the derivative will first have to be calculated for the problem as the derivative of sine square of 2x with respect to sine square of 2x. So first derivative will be a raised to sine square 2x log a times the derivative of sine square of 2x with respect to sine 2x, which will be equal to 2 times sine 2x. So the final answer would be a raised to sine square of 2x times 2 times sine 2x times log a. We can work with any other standard form. For example, the standard derivative of sine x with respect to x is cos x. So d sine x by dx is equal to cos x. Instead of x, we can have x cube plus 4x square minus 3, any other polynomial. And whatever polynomial we have, if we take sine of some polynomial uh, with respect to that polynomial, so derivative of sine of a polynomial with respect to the same polynomial will give us cos of the polynomial. We can have another function as a raised to x. So d sine a raised to x, d a raised to x will be equal to cos a raised to x. Variation can be brought in again by recognizing different forms in which a thing can be put. The cos 2x is 1 minus 2 sine square x. If you do not know that, you can go back to our video on trigonometric ratios of sine of x plus y, or expansion of sine x plus y, cos x plus y, and their use, which is available on this channel. So sine of a raised to 1 minus 2 sine square x is same as a raised to cos 2x. If you recognize this, then the form becomes sin x by dx, and you will have the derivative as cos of a raised to cos 2x. The same principle can be used for obtaining different questions for the other derivative. D cos of x with respect to x equals negative of sin x. So instead of x, we can use log x, and we will have d log x of cos log x will be equal to minus sin log x. While writing the substitution, you can use a substitute log x is equal to y and work your way through it in presentation. But you should never be afraid of seeing a large expression. So fear factor, if you remove the fear factor and recognize that functions can themselves be treated as variables, it becomes easy to solve most of these questions. So try to overcome your fear of expressions and learn to see through the expressions. For example, 3 sine x minus 4 sine cube x is sine 3x. And you can use that to frame a question like d cos of 3 sine x minus 4 sine cube x. Many students are afraid to see such a long expressions. There is nothing to be afraid of. Most of these things are paper tigers. So you can see that the derivative of this expression would be negative of sine of sine 3x. The derivative of log of x with respect to x is 1 over x. And this fact can be used. Again, replacing x with different functions will give you the design of questions. And of course, you can put in equivalent forms. For example, if you have cos 3x, you can put in the equivalent for cos 3x. Or if you have a plus b x plus 1 whole cube, for example, you can use the polynomial expanded form and ask for derivative with respect to it. So log of sine x square, if you take sine square x, d of log of sine square x with respect to sine square x will be equal to 1 over sine square x. But that same thing, if we put in different form, d of log sine square x with respect to x now, instead of the same variable, we will have to use the chain rule and we can compute through it. So d log sine square x by d sine square x times d sine square x by dx, which will be equal to 1 over sine square x into d sine square x with respect to sine x, because we know that square x is to n standard form. If we use that standard form times d sine x by dx. So it's combining three different standard forms using the composite function chain rule. And we can calculate it to be negative 2 of cot x. Here are some standard forms. D of tan x with respect to x is sec square x. D of e raised to x dx is equal to e raised to x. D dx of cot x is equal to minus cosec x. You can transform these questions using different functions and identities in place of the variable x. Try to do it. If you work even on one question a day for several days, you will master these ideas. There is much more to come. Please stay subscribed to our channel. Thank you for watching.